It's the cause behind our everyday action. It's how you and I go to school. It's how your mothers walk to the market every day. So you can see the importance of motion. Without motion, there would be no black holes, no Big Bang, no evolution. There would be nothing. So it's really important. But what if I told you that thousands of years ago, people once believed that motion is just an illusion and it's not real? My name is Wu, and today I'm going to show you 3 paradoxes of motion that almost redefine the definition of it. So firstly, I'm going to go into the definition, and then I'll show you the 3 paradoxes. Okay, let's start with the definition of paradox. So what is it? So paradox is an argument that sounds logical, yet the conclusion of it contradicts itself. So it sounds correct, but it's absurd at the same time. So for example, here, this statement is false. If this statement is false, then it's actually true. And if it's true, then it's false. So the circle keeps going and going. It's a paradox. Another example is this shape right here. This shape could not exist in the real world that we're living because it defies all dimensional rules. So next I'm going to talk about Zeno. Who is he? He's the father of the 3 paradoxes that I'm going to introduce to you guys today. He was a Greek philosopher, and his work really triggers the minds of the scientists at that time. Alright, so here we go. Firstly, the first paradox is Achilles and the tortoise. So Achilles, I think you guys all know, he's the greatest hero in the Greek time, and he represents strength, speed, and the turtles apparently does not represent that. So it's the race between Achilles and the turtle is actually a little bit strange. So before I show you the demonstration, Before I show you the demonstration, I'm going to introduce a little bit about this paradox. So the turtles challenge Achilles to a race, and with one condition, that the turtle will receive a head start of 10 meters. So when the race starts, Achilles starts rushing forward to catch up to the turtle. And when he reaches the turtle starting point, which is about here, the turtle has already advanced about 5 meters. He does this again, and when he reaches the turtle's second destination, the turtle has already moved like 2.5 meters. And this keeps happening. The distance between Achilles and the turtles does get smaller, but there's always this one tiny bit of distance between them. So Zeno concludes that in real life, no one can catch up to someone that's already ahead of them. And motion, it's something, just an illusion. So, to further explain this paradox, I'll go into the second one, which is the Chernobyl paradox, which is the paradox of cutting things into half. So, for example, if I want to walk from here to there, the distance of 2 meters, firstly, I'll have to walk 1 meter. 1 meter from here. And then I have 1 meter left to travel. I have to walk 1/2 of a meter. And then again, I'll have to walk 1/4 of a meter, then 1/8 of a meter. The distance between me and that destination is always getting closer and closer, but it never gets close to 0. It's never actually 0. So in real life, we actually travel 2 meters. So how is this possible? We need to prove that the sum of all the distance that we walked equals to 2. So here's the solution. So if we set the distances that we travel to s, as you can see, 1 plus 1 over 2, 1 over 4, 1 over 8, keep happening like that. And then if we multiply s by 1 over 2, we should get here 1 over 2. So I put it here, and then 1 over 4, 1 over 8. And then if we subtract 2 of these guys together, we should get to a conclusion that 1 over 2 of S is 1, and that S is 2. So Zeno's paradox is actually wrong, because the distance we travel is actually 2 and not getting closer to 2. So here's the last paradox of Zeno, which sounds pretty absurd. So flying arrows is at rest, that's what he said. Here's how he get to that conclusion. Firstly, he said that if an object occupies the space of its own size, it's at rest. For example, this laptop right here, it occupies the space of its own size, so it's at rest, it's not moving. Secondly, he said that time consists of instants, which means small parts of time can be divided into small parts. And lastly, he said that at any instant, the arrow is at rest because the arrow occupies the space its own size when it's flying. So he said that anything that's moving is actually at rest, and movement is an illusion and it's impossible. So that's obviously wrong, right? I'm moving right now. So where's the flaw in his paradox? So firstly, time cannot be divided into 0-second intervals, as he said. Because if we add up all these intervals together, we will get 0 second. And that is not the time of the flying arrow. And the second is the arrow is, yes, it's at rest, but it's at rest at different places. It's here at 1 second, but it's another location in a different time. So scientists think of this and redefine motion is that motion is something that is in different places at different time. So that's the flaw in his last paradox. So don't need to worry, motion is real. You can still get to school, and your mother can still buy fishes for your dinner. So thank you for your attention, and that's the end of any questions?
What are some
Yes, sir.
okay? My question is, what are some implications or applications of these three paradoxes? Why do they exist?
I think that the one reason that they exist is because Zeno wants to challenge the minds of the scientists at that time. He thinks that he wants to make them think more about motion, and that's why they redefine motion. It's not something that is at rest at one. It's at rest at one position at one time, but it's at rest at different location at different time. So the redefinition of these paradoxes really helped the modern physics advance. Yeah.
So again, what are some implications for students like us or for current scientists that we can deduce from these paradoxes?
I think that it triggers our mind a little bit, because when you think about it and not looking at the solution, you might actually think it's real. With the formulas and theory that Zeno deduced, from our perspective, it's actually true, and from thousands of years ago, it's also kind of looks real. So it triggers our mind and for us to think that not to look at one problem in one direction, but in multiple angles.
So they are more like a kind of brain teaser,
yes,
or games for
it's
brain?
more applicable for scientists than us.
Mm. Yes, so can you clarify a little bit more about the roles of brain teaser, or the roles of looking at one issue from different perspectives, the role of doubting our own opinion and our own beliefs?
Okay, so if you look at a problem at one angle, you might not be able to find a solution, and you might be able to, just believe it that it's that way. The problem cannot be solved, and the future is doomed. But if you approach it in a different angle, a different direction, you might be able to see something that's hidden in front of your eyes all the time, and see something, maybe the solution or maybe something better like an invention. So it's really important to look at things in different directions.
How did you come across these paradoxes? Where did you get it?
I watched the video of 10 paradoxes, top 10 paradoxes, but this is just one of this is in the top 10, and I think it's related to physics and science, so I brought it here. The other 9 is not kind of relevant, so.
Okay. Any other questions, everyone? Do you like paradoxes? Do you like philosophy?
Quite.
Okay. Does it mean, or did you say Zeno were both a scientist and a philosopher?
He is actually a philosopher, but his work influenced the scientists.
Oh.
Because he thinks all this nonsense stuff, and then it triggers the scientists to think more about motion and infinity and stuff like that. He's not actually a physicist. Yeah.
Okay, thank you very much for your presentation.